Hello, today we are working on section 7.3, day 3, all the different types of angles in a circle, central, inscribed, interior, and exterior, all mixed up. So we have a bunch of examples here and we're just going to plug through. Next to each diagram, give the name of the angle shown, write down the formula that is used to find its measure, and we're also going to talk about classification, about how that was formed. So looking at this first one right here, that angle out there, angle X, that is an exterior angle. Okay, classification now. How was that angle formed? Was it formed by a radius and a radius, a chord and a chord, a secant and a chord, a tangent and a secant, etc.? Well, remember, tangents are lines that just skate right along the edge of the circle. So this is a tangent. And down here, likewise, this is a tangent. So this is formed by a tangent and a tangent. If you don't remember the names of these, or the definitions of these vocabulary words, tangent, secant, chord, etc., pause the video, go back to your notes in section 7.1 and look at the very first page. All these definitions are on that very first page. Formula for an exterior angle is that the angle is 1/2 of the big arc minus the little arc. For this next one, vertex is at the center, so this is a central angle. And how was that formed? Well, that angle was formed by a radius here and another radius here. And the formula for a central angle is that the angle is exactly equal to the arc. Number 17, this one right here. That is an inscribed angle because its vertex is on the circle. Okay, now what's it formed by? We have a tangent right here. That's tangent line because it's outside the circle and it skates right along the edge. And then this is a chord. Since it's a segment that has its two endpoints on the circle, that's a chord. So this is formed by a chord and a tangent. If you wrote it the other way around and wrote tangent dash chord, that's perfectly acceptable. And this angle for an inscribed angle is 1/2 of the arc. Number 18, again we have an exterior angle. And the exterior angle, this one is formed by a secant. Since this segment here actually extends outside of the circle, it's a secant. And this is also a secant. Okay, and exterior angle, 1/2 the big arc minus the little arc. And down here for number 19, that angle is on the inside of the circle and it's not at the center, so we'll call this an interior angle. And it is formed by two chords. And an interior angle is 1/2 of its arc plus the arc of the vertical angle. Vertical angle, VA there. If you don't think you're going to remember that, then jot that down, that's vertical angle. And as I was doing this, I realized that there's something else I could tell you about the very first one that we did. Some of you may have recognized this. This is an ice cream cone situation. So for this situation only, you could use that the minor arc plus the angle equals 180. And that's only for this ice cream cone. For this exterior angle formed by two tangents. Okay? Moving on to the next page here. Number 20. We have another inscribed angle. And that is formed by two chords. And at inscribed angle, 1/2 the measure of its arc. For number 21, this is an exterior angle, and it is formed by, what's this? Yes, that's a tangent. And this one here, we have a piece that extends beyond the edge of the circle. That's a secant. Exterior angle, 1/2 big arc minus the little arc. All right, now those we just described the angles. On this next set, we're going to do all of that, and we're going to find the value of the x. So one step further. And the key question when you're doing these types of problems is, where is the vertex? Where is the vertex? That's going to tell you which formula to use. So for each of these, we have to identify the type of angle shown, interior, exterior, central, or inscribed. We have to identify how the angle was formed. So chord, chord, radius, chord, tangent, chord, yada, yada, yada. Write the appropriate formula, and then solve for x. So here we go, 22a. Identify the type of angle shown. Vertex is on the circle, that's inscribed. Part B, identify how the angle was formed. That's a chord and a chord. C, the formula for an inscribed angle. Angle is 1/2 the arc. And D, so we want to find that. So that angle is 1/2 of that arc. So x is 35. Well, technically I don't need the degree symbol since the degree symbol is in the problem. Okay? Looking at 23, we have another inscribed angle. Vertex is on the circle. Again, formed by a chord and a chord. Chord is a segment whose endpoints are on the circle. Formula, again, angle is 1/2 the arc. Now this time they want you to find the arc, not the angle. So if the angle is 50, then this arc out here is 100. Let's see, A, what type of angle is that? Oh, that's an exterior angle. B, what's it formed by? Those are two secants. Right there would be a chord, and when we take that chord and extend it beyond the edge of the circle, it's a secant. So this is a secant, secant. And C, the formula, The angle is 1/2 of the big arc minus the little arc, and D. Okay, we want to find X, so I'm just going to plug right into that formula there. We've written there 1/2 big arc, 90, minus the little arc, 70. 90 minus 70 is 20, half of 20. I'm running out of room here. Can we squeeze it in? X equals 10. Okay, 25. I'm going to start this problem up a little bit higher on the page so I have some room to work through. Let's see, exterior angle. Again, a secant and a secant. Formula, angle is 1/2 big arc minus the little arc. Okay, plugging in this time. The angle, 40, is 1/2 the big arc out here, that's X, minus the little arc, 25. I'm going to multiply both sides by 2 to clear the fractions. This side becomes 80. On this side, when we multiply by 2, the half goes away, and we're left with X minus 25. Add that 25 over, and X is 105. Again, one nice thing about the videos, I mean, it kind of stinks that you can't ask questions as we go along, but you can pause it and rewind and hear it again if you need to, or if I'm going too fast and you missed something. Okay, next page. All right, still plugging through. Let's see, what kind of angle is it? That is an exterior angle. And it is formed by 2 tangents. All right, now this is an ice cream cone. So you can use that the angle plus the little arc equals 180. It only works for this ice cream cone situation. So look over here at 27. It's not going to work for that one. Will not work. It'll only work for this ice cream cone, this tangent, tangent. Okay, that means these two guys add up to be 180. So you can just do 180 minus 42, and X is 138. Now this time I do need the degree symbol on it because there was no degree symbol in the problem. Again, I'm being picky with that. It is not something I will test you on, so don't worry about that. If you put the degree symbol when you're not supposed to, or if you don't put the degree symbol when you are supposed to, not a problem. Don't worry. 27, this is another exterior angle. Formed by a tangent and a secant. And exterior angle, angle 1/2 big arc minus the little arc. And let's see. Oh, plug it in. So X equals 1/2 big arc, 110, minus little arc. Uh-oh, that's not there. It's this piece right here. But we definitely have a diameter sitting right here. So 180 degrees. In this arc across the top, this semicircle, that's 110 That leaves 70 right here for the little arc. So we can pop that in. Okay, 110 minus 70 is 40. And half of 40 is 20. Here we go. 28. This is an interior angle. It is formed by two chords. And let's see, the formula angle is 1/2 of its arc plus the arc of the vertical angle. Plug in right in here, this angle X is 1/2. Its arc is 80 plus the arc of the vertical angle, 100. So we have half of 160, which is 80. Oh, it would be nice if I could add, don't you think? Well, I can add, I just goofed. So some of you guys are panicking here. Don't panic, we're going to fix it. 80 plus 100 is not 160, it is 180, which means that half of 180 is not 80, it's 90. I'm sorry about that. Okay, 29. We have an interior angle formed by two chords. And the formula, angle 1/2 arc plus arc of the vertical angle. All right, subbing in the angle this time we know is 105, 1/2. Its arc is 100 plus the arc of the vertical angle, there's your X. Okay, again, I'm going to multiply by 2 to clear the fractions. That makes 105 times 2 makes that 210. On the right side, when you multiply by 2, this half disappears, and you have 100 plus X. Subtract off that 100. That's going to be 110. Right there. Okay, now for the best part. I love these problems. Oh, it's very exciting. Oh, look at this. Doesn't it look fun? We have to find all the angles here. All the angles that are numbered, 1 through 10 down here on the bottom. I'm going to have to shrink this down a bit so that we can see the entire page all at once, or most of the page. There we go. Oh, I love these. Okay, so there's kind of a procedure that you go through, kind of the order that makes it the easiest so it's not quite so scattered and all jumbled up. First thing that we are going to do is we are going to mark all of the information that was given to us in the problem. So arc AB is 100. All right, AB, there's 100. Measure of arc BC is 30. And measure of arc EG is 50. Okay? All right. Now, let's do this. We need to find all the other arc measures that are up there. So when you do this, the first thing you're going to do is you're going to identify all of the arcs on the diagram. We're going to find all of those. So start looking for diameters. Oops, looks like this dot got bumped a little bit in the printing. That point right there is supposed to be right here, so that is the center. So we're going to start looking for some diameters. I see a diameter right there. So all of this has to be 180 degrees. There takes up 100. That takes up 30. So that's going to leave 50 down here. 180 minus 100 minus 30 leaves 50. Let's see, another diameter, if I go to the other side over here, well, I got this arc is 50, but I have two pieces. I got this one and this one, so I can't do anything with that. Let's look at the other diameter. How about this one right here? Okay, so top half, we got there, or that half, that's got to be 180 degrees. There's 30 here and 100 here. It's 130. That leaves 50 for that piece. Oh, now we can get the last one to this diameter. We got 50 and 50 is 100. That leaves 80 for this. So find all the arcs. All right, now I tend to group these together and do all of one type of angle all at once so that I can be focusing on just one formula. So the next angle type or the first angle type, once you get all the arcs, the next thing I want you to look for is all of the central angles. All of the central angles. So central angles have their vertex at the center of the circle. And there's only one of them. It's angle 3 right here. And we know central angle is exactly the same as its arc. So I'm going to follow the sides of angle 3 out till it hits the circle. And here's its arc. This 50 and this 80. And 50 and 80 is 130. So angle 3 is 130. Okay, once you got all your centrals, now move on to your inscribed. And inscribed angles are going to be ones where the vertex is on the circle and it's half of its arc. So we just start looking, where do we see inscribed angles? And there's a bunch of them. First one I see is this angle 8 up here. And there's nothing that says that you have to answer these angles in order. I don't usually. All right, so there is an inscribed angle, which is going to be half of its arc. So if we follow the sides of angle 8 out, it's going to give us this 80-degree arc in here. So the angle is half of that, or 40. Okay. Another inscribed angle right next to it is at angle 5. Inscribed angle, half of its arc, so if we follow the sides out from angle 5, it's going to be this 100-degree arc. Half of 100 is 50, so angle 5 in here is 50. Let's see, other inscribed angles. Oh, here's one right here at 2. Follow the sides of 2 out till it hits the circle. And we have this 130-degree arc here. 130, half of 130 is 65. Okay, you know what? All these have degree symbols on them. It's just me being picky. All right, one last inscribed one. I think there's one more. Oh yeah, 9, right here. Here it is. Follow the sides out. It hits this 80 and this 50 hits 130. Half of 130, so angle 9 is also 65. Can you see those on the bottom down there? Okay, once you have all the inscribed angles, then I go to interior angles next. It doesn't matter that you go in this order. You can do it in any order you want. You can do them all mixed up. Personally, I just find it easier to focus on one type of problem at a time. Okay, so my interior angles that are on the inside of the circle but not at the center, I see two of them. Do you see two of them as well? There's one of them right here. Angle 1 is interior, and angle 6 is interior. So let's start at angle 1. And I'm just going to jot that work over here to the side. Angle 1. And we know it's going to be half of its arc plus the arc of the vertical angle. Its arc, if I follow the sides of angle 1 out, follow the sides, that's going to be 130 is its arc. Now I got to take the vertical angle and slide that out, 50. 130 plus 50. That's half of 180, which is 90. So angle 1 is a right angle. All right. Let's look at the other one, angle 6. Angle 6, 1/2 of its arc plus the arc of the vertical angle. Its arc is 50 plus arc of the vertical angle, 100. That's half of 150, or 75. Angle 6 is 75. Okay? One last type. What's the one last type that's left? Exterior angles. Okay, if we look at our diagram, where's our exterior angles? Well, I see one here at 4. So I'm just going to do that work over to the side. Angle 4 is 1/2 of the big arc minus the little arc. So sometimes I find the little arcs first because they're the ones I'm going to hit the circle first. So my little arc is right there, is 30. Big arc, keep following the sides out, and that's 100. So we have 1/2 of 70, which is 35. So angle 4 is 35 degrees. Okay, other exterior angles, I think the last two are up here at the top. So we have a 7 and a 10. Let's start with 7. I'm going to put the work up here for 7 so I don't have to keep moving the paper. Angle 7, 1/2 of big arc minus the little arc. Okay, so follow the sides of angle 7. Oops, where it hits. Right there. 50 is the little arc. Big arc, it's tangent, so it's got to stop right there. But if I follow this side out to where it hits down there. So this arc, 130. We have 1/2 of 80, or 40. So angle 7 is 40. That pops that in down here. And the last one, angle 10. Now it's a little tricky to see, but see how there's this arc drawn in here? So angle 10 is actually all of this. This part is 7, and then this unlabeled angle over here. So all of it, all of that. Angle 10 is an ice cream cone situation. See how it hits both two tangents there. So angle 10 was formed by two tangents. So we know that this angle 10 plus this arc of 100 has to add up to be 180, which means angle 10 is 80. And there we go. Wasn't that fun? It's like a jigsaw puzzle. I love those problems. It's very exciting. All right, so just to reiterate on this last one, if you go through it, some sort of set method of doing it rather than just going scattered all over the place, you're going to find these problems a little bit easier to handle. Again, this is the order that I go through. I would strongly suggest that you do all of the arcs first, then focus on the angles. This is the order I tend to do them in. Again, you don't have to do them in this order, but some order or some procedure will help you work through these. Okay. Oh, we need a question for today. I'm trying to look around my desk to see what I can ask you about. Oh, okay. What's this? It's a binder clip. And isn't this cool? Because it's got a little smiley face on it. So your question of the day is, what school supply item did Mrs. Rachel show you? And your answer is a pink binder clip with a smiley face in it. All right. Thank you very much for watching. Have a good day. And go ahead and you can do the 7.3 day 3 homework now.